Hello everyone, welcome to Vindhyavasini Academy. Before proceeding to the next lecture of photosynthesis, we should have a basic idea about light and energy. As we knew, light play an important role in photosynthesis. In our previous lecture, we studied the equation of photosynthesis. That is, carbon dioxide plus water in the presence of sunlight and chlorophyll, it will form carbohydrate and it will evolve oxygen in environment. So the light energy which fall on the surface of the leaf is in the form of photon of, or we can say quantum of light. So what is this photon? Photon is a discrete quantity of energy. This discrete quantity of energy in the form of photon fall on the surface of the leaf. So if we calculate the energy of a single photon, it is equal to E is equal to h nu, where h is Planck constant is equal to 6.626 into 10 raised to power minus 34, and nu is frequency. We can also write nu as c upon lambda, where c is equal to speed of light in vacuum. It is equal to 3 into 10 raised to power 8 meter per second. And lambda is wavelength. Lambda is wavelength. Not all color of light have equal energy. So let's understand this line with the help of an example. If we calculate 1 mole of photon of blue light, the energy will be 240 kilojoule. And if we calculate 1 mole of photon of red light, the energy will be 170 kilojoule. Why is it so? According to the above formula, E is equal to h nu, right? And we can also write c upon lambda in the place of nu. So we can also write energy is inversely proportional to lambda. Energy is inversely proportional to lambda and energy is directly proportional to nu, that is frequency. So if the wavelength is low, the energy will be high. If the wavelength is high, the energy will be low. So if we took 1 mole of photon of blue light, 490, the energy will be more. And if we took the red light, that is 700 nanometer, the energy will be less. In oxygenic photosynthesis occur in the visible range, that is 400 to 700 nanometer. So before understanding this, we should have a basic idea about electromagnetic spectrum. So this is an electromagnetic spectrum from gamma rays to the radio waves. If we move from gamma rays to the radio waves, the energy will low and frequency will low, because energy is directly proportional to frequency. High energy and frequency will be high in gamma rays. But as we move from gamma rays to the radio waves, the energy will be low and frequency will also low. On the other hand, energy is inversely proportional to the lambda. If we move from gamma rays, the energy will be high, but the wavelength will be low. And if we move from gamma rays to the radio waves, energy will be low and the wavelength will be high, because energy is inversely proportional to lambda and energy is directly proportional to frequency. So the visible range for the oxygenic photosynthesis is visible spectrum from 400 to 700 nanometers. This visible range consists of 7 light rays, which is Vibgyor. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. This Vibgyor region is also called PAR. And what is PAR? PAR is photosynthetically active region. Photosynthetically active region. In this region, oxygenic photosynthesis occurs. Right? So what happens when a pigment molecule absorbs photon, energy of photon? So let's see, it is a pigment molecule. It is present in its ground state. When a photon of energy fall on the surface of the pigment molecule, it will shift from its lower energy molecular orbital to its higher energy. It will move from its lower energy to its excited state. We can call it as excited state. So if a pigment molecule absorbs short wavelength, it will move to a higher excited state. On the other hand, if it will absorb wavelength of longer wavelength, it will move to lower excited state. In our previous slide, we studied energy is inversely proportional to lambda. If the lambda is low, energy will be high. So, if a pigment molecule absorbs light with a shorter wavelength, the energy will be high. It will move to a higher energy orbital. For example, if a molecule absorbs blue light, it will move to a higher orbital. And if a molecule absorbs light with a longer wavelength, that is red light, it will move to a lower energy state. So if a molecule, when moved from its ground state to an excited state, it will again come to its ground state, because excited state is an unstable process. Because excited state is an unstable position. So a molecule want to return to its more stable position, that is a ground state. So molecule will do this. So the molecule will return to its stable ground state in three simple steps, or you can say that in three steps. First, it will release energy in the form of heat. So the molecule will release energy in the form of heat, and it will come to its ground state. Another is emission in the form of photon. This process is called fluorescence. It will emit energy in the form of photon. This process is known as fluorescence. Or the third step is the most important step, energy transfer. The molecule will transfer energy to another molecule which is present to its close proximity. So how it will do? For example, if a light energy fall on the surface of a molecule, it will transfer its energy to its another molecule, then it will transfer its energy to another, then it will transfer its energy to another, then it will transfer its energy to another. Right? So the pigment molecule move to its more stable ground state from the excited state by the three methods. First, it will evolve heat. Second, and it will emit photon. Third, energy transfer. In the last step, we will study the molecule exists In molecule, two type of excited state can exist. First is singlet state and the second is triplet state. While singlet state is short-lived, antipolar spin found in singlet state, and polar spin found in the triplet state. So why it is called singlet and why it is called triplet? So let's understand this with the help of an example. For example, an electron spin, an electron is present in its ground state. When the molecule is excited and move to its singlet state, it will move like this because in singlet state antipolar spins found. Then an electron move from a triplet state. The electrons spin like this because in triplet state polar spin found. So why it is called singlet and triplet? So let's understand this with the help of an example. 2s, s is equal to 2s plus 1. So what is s? It is a total number of spin. It is total number of spin. If we calculate for singlet, in singlet there is opposite spin for an electron. This is plus half and then this is opposite, so this is negative half. We can put here plus half, negative half. Plus half, negative half cancel out. So 1. So that is why it is called number of spin is 1. Total number of spin in singlet state is 1. That is why it is called singlet state. If we calculate the total number of spin for triplet state, we can put this in this formula. For triplet state, the electron spin in polar direction. So if it is plus half, this is also plus half. 2 plus half 1. 2 into 1 plus 1 is equal to 3. So the total number of spin in triplet state is 3. That is what is called triplet. So in singlet state is short-lived and antipolar. Singlet state is short-lived and antipolar. Whereas triplet state is long-lived and polar. TLP, it is SSA. So a question is asked in CSIR NET 2019 June. After absorption of light, chlorophyll molecule in green plant exists in singlet and triplet state. Which of the following statement is correct? So let's read one by one. Option A, singlet state is short-lived compared to the triplet state. That is right. We studied SSA. Singlet state is short-lived. So this option is correct. And option B, singlet state is long-lived. Wrong. Singlet state is short-lived. So this option is wrong. Coming to the option C, singlet state contains electron with antipolar while triplet state has electron with polar spins. Right. SSA, single state have antipolar spin. So this option is also correct. Coming to the D part. Singlet state contain electron with polar. This is wrong. Polar is found in triplet. So option A and option C is correct. Where we can find this combination? We can find this combination in option C. So according to this question, option C is correct. Option C is correct because SSA found in singlet state and TLP found in triplet state. What is SSA? SSA is singlet state, short-lived and antipeller. And where what is TLP? TLP is triplet state, long-lived and peller state. So I hope you like this video. If you like this video, please like, subscribe and share with your friends. Thank you for watching.